Scientists have given personality tests to spiders. The spiders had personalities. Some were bold, some were shy, and the same spider stayed bold or shy for its entire life, across weeks, across situations, whether or not it made any sense. This wasn't a joke study. It's been replicated in fish, in birds, in mice, in octopuses, in hermit crabs. Which raises a question most of us have quietly assumed we already knew the answer to. Do animals have personalities? Let's start with what the question is actually asking. Because personality is a slippery word, and most arguments about this are really arguments about the definition. When biologists say an animal has personality, they don't mean it has a sense of humor or a favorite color. They mean something narrower and much easier to test. They mean the animal behaves consistently, in a way that's different from other members of its species, and that this difference holds across time and across situations. That's it. If a mouse is more cautious than other mice on Monday, and still more cautious on Friday, and still more cautious in a completely different room, that mouse has what researchers call a behavioral syndrome. Most scientists avoid the word personality in papers. Then they use it constantly at conferences. The definition matters because it rules things out. A dog that's scared of thunderstorms doesn't have a personality trait. It has a response to thunderstorms. The trait only counts if it shows up when there's no thunderstorm. If the dog is also the one hanging back at the park, also the last to approach a stranger, also the one who waits while the others investigate the noise. Consistency across contexts is the whole test, and it turns out an enormous number of animals pass it. So how do you measure this? Researchers generally look at 5 axes, which appear again and again across species. Boldness, how an animal responds to risk. Exploration, how it handles somewhere new. Activity, how much it simply does. Aggression, how it treats rivals. And sociability, how much it seeks out others of its kind. These are not the human big 5 personality traits, though the resemblance is not a coincidence. They're what you get when you strip personality down to the parts you can watch an animal do. And the tests are wonderfully unglamorous. You put an animal in an unfamiliar box and time how long before it moves. You drop something novel into its enclosure and see whether it approaches or retreats. You poke it gently and count the seconds until it comes back out. Then you wait a month and do the whole thing again. If the numbers match, you've found something stable. If they don't, you found an animal having a bad day. Consider the animal that turned this whole field into a science, the great tit. A small, common European bird that most people have walked past without noticing. At the Netherlands Institute of Ecology, researchers including Piet Drent and Niels Dingemans have been running exploration tests on wild great tits for around 30 years. Think about that. That program has now tracked more bird generations than most people have relatives they can name. The test itself is simple. Release a bird into an unfamiliar room and record how quickly it investigates. Some birds tear around the space within a minute. Others sit still and watch. The differences are large, they're measurable, and here's the part that matters. They're stable. The fast birds stay fast. Months later, in a different room, the same individuals behave the same way. Then it got stranger. When researchers selectively bred fast explorers with fast explorers, and slow with slow, the offspring inherited the tendency. Estimates put the horizability of exploration behavior at roughly 30 to 50%, comparable to the horizability of human personality traits, which sit in a similar range. Which means that whatever this is, it isn't only learning, and it isn't only mood. Some of it is written down. And great tits are not a special case. Once you know what to look for, it's everywhere. Hermit crabs, poked with a stick, show startle responses so reliable that the same crab makes the same choice for months. A hermit crab runs on roughly 100,000 neurons. You have about 86 billion, and yet the crab manages to be consistently, recognizably itself. Octopuses in labs get informally sorted by keepers into the ones that will squirt you and the ones that won't, and the sorting holds, though that's an anecdote, not a study, and it's worth saying so. Fish are where it gets awkward for us. In pumpkin-seed sunfish, researchers found that the bold individuals swam into traps and the shy ones stayed out. The bold fish were caught first by a wide margin, which means the trap wasn't sampling the population, it was sampling the extroverts. A lot of what we know about fish behavior was collected using exactly this method, from exactly the fish willing to enter a box. But why would evolution allow this? That's the part that took the longest to explain. For a long time it looked like a problem. Evolution should produce the optimal animal. There should be one correct level of boldness, enough to find food, not enough to get eaten, and every individual should converge on it. Personality variation looked like noise, like evolution failing to finish the job. The current thinking is close to the opposite. The optimal level of boldness depends on conditions that keep changing. In a year with few predators, bold pays. In a year full of predators, shy pays. Neither strategy wins permanently, so both persist. Variation isn't a failure to optimize. It's a hedge against a world that won't sit still. There's a second explanation that's more uncomfortable. Being consistent may itself be useful. A bold animal that's predictably bold can be relied on by others, can specialize, can get good at one thing. Flexibility sounds superior, but flexibility is expensive. It takes brain, time, and attention. Sometimes the cheaper solution is to pick a personality and commit.